Sending it over to my screen.
I am going to... There we go. You should be able to now.
Okay. One of the big things is in the curriculum, we had somebody ask a question as far as the transfer system itself. You kind of want to make sure each one of the units is broken up with a teacher's notes section. And we've tried to put some things in the teacher notes that aren't necessarily in the curriculum. Like one of them is down here in the answer keys is one that says transfer system assembly. What it is just a Word document that with images step by step can show the kids the one that's actually from the curriculum, how we would put that together. So if you're looking at size-wise and everything, there is not really a size. You kind of need to decide the sizes on how much room do you have to store them. It typically says, there it goes, it says in the curriculum that it's supposed to have 12 inches worth of travel. Well, every once in a while I'll get some kids that think a little bit independently, think a little bit differently and say, well, it says 12 inches of travel, but it doesn't say 12 linear inches worth of travel. So they'll make a circular system and calculate the circumference of it so that it's still traveling within 12 inches. I've had some that are doing some kind of drop system where it's a zigzag kind of going back and forth, and they're minimizing the amount of travel that it has. But you have an actual document that will go through and show them step by step how to build one of these if you wanted to build the one that's actually in the curriculum, the little pictures that are there. So I have found that if you've got students trying to go off of some of this, a lot of times it will take them longer if they're trying to follow a set of instructions and trying to build something themselves. But it also teaches them a little bit about how to build things correctly. Most of the kids, they're hacks. They have no formal training on, yeah, this is a conveyor belt, so what they do is they put a gear on one end, they put a gear on the other end, and they pull the thing nice and tight so that it doesn't sag in the middle. They don't think anything about, there should be support under this. There actually should be slop in it, otherwise I'm binding up the gears and those kinds of things. So even if I don't have them build it, there's a lot of times I can have them go through the pictures just to start looking at the philosophy of how one might be built to withstand some kind of stresses and not put so much torque and bind up the motors to where I'm burning out the motors because the motors are working so hard. And when they start getting into servos, they easily burn out servos because they truly don't understand the philosophy of a servo. But this is in the curriculum, and it's into the teacher notes section. One of the requirements that we have as far as your PDP goes is you have, which most people have been taking care of, you've got your week ahead prep, you have your, whatever they're calling it, so you've got your week ahead preps, and then you've got your observation of how your week went in the past, your reflections, and then you also have the student work discussions. Chris and I are going to put together a list. Rather than having every single one of you have to turn in work discussions, we're going to have each person each week turn in one. So, Megan, it may be yours the next time that we have a meeting is to bring some kind of student assignments. And then rather than use up a whole lot of our time during our meetings, I think we'll just try to make it a discussion where everybody will get on to the LMS when you have time and just make some comments about it. So rather than everybody have to do one and us spend a good portion of our time, we would rather spend that time on software, and we can try to do these discussions a little bit later. But I brought one today. So here is an AGV follow-up. This is the PLTW CIM follow-up. It is in the curriculum, and the kids are basically just supposed to edit it. Unfortunately, the one they have now put in the curriculum, I think, is a PDF. So what I had to do was take the PDF and turn it into a document, which I give my kids both a Word document and a Google Doc, and they decide whichever one's going to work best for them because they have Chromebooks. So they put their main photo on there, and hopefully everybody can see my screen. I think you can see my screens.
Yep.
Okay, so they fill out their form. They put their name and whatnot on it. I have the kids get in their own groups of 3. They have an electrical engineer, a programming engineer, and a mechanical engineer, and every kid has to fill out one of these follow-ups. So I don't allow them to do that by team. So once they've got it, they do an abstract. What was the whole meaning of it? What were the concepts that were to be taught? What's the material list? And then their procedure. They're supposed to go through step by step. What do they do to build it? What does the programming look like? He's got all of his screen captures, all of his snippets and everything. Any kind of concept sketches that they had, they're supposed to have those. And then they have a conclusion statement and references. So, I force the kids to do a good job here. But once they leave my classroom, other than the container and a couple little things that they're going to do second semester, they don't have any takeaways. I'm not going to let them take them Vex with them. So photos and imagery and pictures of programming, that's all they're going to have. If they're not at a computer that has RobotC, then they'll never be able to open up a RobotC file again. So screen captures and everything, you really want to encourage them to try to get and try to do a good job with it. So all in all, this one wasn't bad for their very first one. I've got some that aren't near as good as others. So if I go back and I look at another student, all of my students, they have shared folders with me, so all they have to do is put things into a folder, and then as soon as they do it, then I'll have them. So if I grab one of these and I look at his AGV and I look at his follow-up, so each team is going to be a little bit different as far as what their images are going to look like. And I have cameras available to them. They can also take pictures with their Chromebooks. They can take pictures with their cell phones, whatever it is that they want. You can see on my tables, this is all they get to test with. They have a straight black line and a cross. So that's really all now they can pick up the tape and they can make a left-hand curve and a right-hand curve with it, but that's just for testing. On the day that they actually have to run them, I take my electrical tape and I make this kind of amoeba shape on the table, and they don't get the test on that until it's test day, and then they put their little project on it and it's supposed to run. So
does each student do a report, or are you just doing one per group?
Every student does a report.
The same in my class too. The written work is what they get graded on. That's the individual portion of their grade in my classroom. And then there are grades that are okay. You've met this benchmark, you've met this benchmark. Those will be group grades, but everybody gets graded on their individual report.
So when I look here, his procedure, he has not even a good screen capture of the program, it's not even a full picture of the program. He has some pictures of the bot, but no close-up images of the ultrasonics, of the line followers, where his storage was, what his drivetrain looks like, and conclusion is very simplistic. So all in all, this follow-up ended up being a fairly low grade. So that's one thing that I wanted to kind of touch on a little bit, was grading. I will show you an example of what I give. Actually, we'll just use his. We're a big proponent in my school about choice and voice, trying to give the students an opportunity to kind of work on their own curriculum a little bit. So mine actually decide how long this project takes. I tell them ahead of time, these are all the things that have to be done, and then they have to sit and create a Gantt chart from me that they learned in IED, and they have to convince me that we need 5 days, we need 6 days, 7 days, whatever it is. And I know in the back of my mind how many days I really want them to have. So I kind of weasel them down to the days that I really wanted, but it really gives them the buy-in for these are the days that we wanted. He gave us those days. Now if I don't get it done, then that's on me. And I do. If they have to go over it, that's fine. They can go over their time, but it costs them a letter grade per day. So they actually have to say, oh, so can I get enough done in one day to warrant losing 10% of my grade? So mine are juniors and seniors, and I'm really looking to try to get them into that ownership. So if you look, They had 10 points for brainstorming, a final sketch. Did it follow the line? Did it stop at the intersection? Did it continue from the intersection? Did they add the ultrasonic? Did they have the joystick? So that's the grade that the group gets. And then they have their individual grades. So the software engineer gets a grade for his description, for pseudocoding, for flow, comments, formatting. Then their follow-up. The mechanical engineer has symmetry, structural stability, design, and then the engineer is kind of the liaison between the mechanical and software. How does the wiring look like? Did they do the cortex diagram? How is the cortex organized? The sensor setup. So they have, these are my things, these are the group things, and then I have my follow-up. So just because their project did not do well, they could still come out with a fairly good grade in the class, fairly good grade for the activity, as long as they do everything else that they were supposed to do. I mean, we're trained to change these kids to be engineers. Engineers fail a lot. We fail almost every time near the beginning. So I don't anticipate that all of them are going to work. And these kids, most of mine that are good kids, they don't know how to deal with failure. They have never had that opportunity where I could get an A and my project doesn't work. Well, yeah. I mean, if I really had the time, then we would keep working on this until it did work.
Right.
We don't have that kind of time.
And
so,
I want to stress too that once you set a deadline, you have to stick with it in terms of because the more you get behind in one, okay, it's only a day, but then the next project it's a day, 3 days, all of a sudden you're missing a whole unit towards the end of the year. So my sim kids are in 10th grade, a couple ninth graders, advanced ninth graders. So I don't give them any choice. It's like, this is the date when it's due, period. And we work it like that.
So at any point in time, if you've got questions about grading philosophies, a lot of it, I understand Project Leadway's mantra about we're not trying to tell you how to grade in your own room. Now, sometimes some of the stuff has rubrics and some of the stuff it doesn't have rubrics. I have to create those kind of rubrics because I want to start teaching the kids how to play the game. When they get into college and they're looking at, okay, this activity's 50 points, this activity's 100 points, this activity's 500 points. Which ones can I perform well on? And so, I mean, rubrics are the big thing that I put together. And I actually make them fill them out. They fill them out, they submit them to me, and I kind of take their opinion a little bit in. Because there's sometimes that they're more harsh on their own grades than I am.
I do that in my classroom also.
Okay, so as far as RobotC, I'm hoping everybody right now is running 4.0. So I have done a fresh install just so I can go through any changes or any settings that need to be fixed. Well, it sounds like most of you have been at least doing the test bed, so a lot of these I think you have already done. Little things like the communication mode needs to be set to USB only. We are recording this, so if you want to be able to go back to it, we're going to try to get you a place for an opportunity where you can see this video, but if you're also taking notes, this has to do with if you untether the robot. If you're no longer plugged into the orange cable, as soon as you try to plug it in and try to run it, it'll sit there and it will blink forever because it's looking for the VexNet. And if you're not using a joystick, then it will never find the VexNet and your program will never run. So that's one of the first things I have the kids do is kick this over to USB only unless it's a project where I do want them to use the joystick. So once that one's set over to USB only, I'll go down to my platform type and I will make sure that I am on the VEX 2.0 Cortex, which hopefully it will be. And then the last one, I want to make sure that I have a check mark on the natural language. If I don't have a check mark on the natural language, then it will not be available over here. Now, I can tell you this year I had several kids' computers where they could not get the natural language to come up for the life of them. And they had changed everything that I asked them to. They had changed the communication mode, they had changed the platform type, and they had checkmarked the natural language, but no natural language. The way that we got it to be successful, one way, is to bump up the menu level. We bumped up the menu level to expert or super user, and that made it pop up on some computers. Others that it didn't, the last solution that worked for them was to open a sample program. And if I come to the folder that says natural language examples, they were able to open up any of these. As soon as they opened up one that had a natural language embedded in it, as soon as they did, the natural language was there, and it continued to be there forever.
And that worked every time on all the computers in my classroom. The opening up, the other one worked sometimes, but not always. But on our network, opening up a sample program worked every time.
And that's just kind of ironic. Like I said, this was a brand new, fresh install. It's never been on this computer before, and natural language was just there. It was not in my lab.
Huh.
I don't know why. I don't know what the big difference is, but my laptop, it just did it. Natural language, as soon as I installed it and checked that box, apparently it's here. Okay. Chris and I have both been to some Carnegie Mellon training sessions. So we wanted to give you a little bit of insight on their philosophy of programming. So if instead of just saying new file, I am going to open up a sample program, and I'm going to go down to the PLTW tab, which they have made for us, and I'm going to open up the template. Have the kids leave this backup alone. The backup is really for you when they mess up the template, because they'll accidentally overwrite the template with one of their programs, and then it won't be blank anymore. So you can just take the backup, make a copy of it, remove the word backup, and then you've got your backup template again. I kind of wish they would have hid it or something from the kids, because then they'll mess up my backup too. Okay, so as far as the program, you know, your project title, team members, all of that I have the kids fill in, and then I get very specific with them about putting in a good task description. A very simple paragraph, a couple sentences or whatever about what it is that I want to do. So what you're trying to teach the kids, you're trying to teach them, I'm going to take my description, I'm going to break that description up into pseudocode, and then I'm going to take that pseudocode and I'm going to write my program. And you'll have some kids that are like, oh, I don't need to do that. It's not really for them half the time. It's more for me, because they'll raise their hand and, hey, my program doesn't work. And I'll come over and I have really no concept of what I'm looking at. If I can read through their pseudocode and I can see their thought process, most of the time I can fix their program. But if I'm just looking at their program, they just kind of hodgepodge. They just start grabbing stuff and pulling it in, and they have no rhyme or reason to what they're really trying to make happen. They can't figure out why it's not working. And it's half the time it's because the sequence, or they're asking it to do too many things. So I'll just do it real quick, and I'm going to say program is designed to start a motor and run it for 3 seconds before stopping. And that's the kind of description that I would look for the kids. Then they're going to break that up into pseudocode. So I'm going to take this whole line and I'm going to try to break it up into a sequence of steps. So I'm going to start the motor, then I'm going to run it for 3 seconds, then I'm going to stop the motor. So stop the motor, oops, and then run it. Why can't I enter? I don't know what's going on here. I can't enter.
Hit your insert. Do you have an insert key on your computer?
Not on my Lenovo, I don't.
You'll find
I was
too.
looking for that.
Kids will.
Yeah, I was looking for that just a second ago.
kids will do that. They'll get to a spot, and when they hit a key, it doesn't do what they think it should. On a computer in my lab, if you hit the insert key, it generally fixes it, and it'll do what they want. And it just happens sometimes. I have no idea why.
Yeah, I found my insert key. There we go. Start the motor. Run for 3 seconds. Stop the motor. Now, I'm very picky on my kids commenting their program. If I can't see their comments, a lot of times I won't even come around and help them. They've got problems. The very first thing I'll do is I'll walk over and I'll tell them, I need to see your commenting. Let me know when your comments are there. And I'll walk away and I'll come back when they have the comments onto their program. Because it's the same thing. It's about trying to get their philosophy. So I have the kids cheat. They grab their pseudocode. They just copy that. They bring it down into task main and they paste it. If this one will let me. Which I can't. I've not tried to do this on my Lenovo yet. Can I copy and can I paste? Nope. Oh well, so their idea is they're going to bring that down and then they're going to put their comment marks in front of it, which they could actually do that up here if they really wanted to, and then copy and paste it. And then all they have to do is go into their natural language and they can drag and drop these right in front of their comments. Because their comments, their pseudocode truly is their comments. So they should be able to say start motor and wait 3 seconds and stop motor, and that's their whole program. And then as soon as they're done, they come up here to a little magic wand. They say fix the formatting, it'll repair it for them, and then they're done. So why can't I copy and paste? But I can't.
And you're going to find, too, on your computers in your labs, if something works and then it doesn't. It seems like it's always something, all these little things. And kids are really good at trying to figure these out. And when they do figure it out, just let them teach the rest of the class. It's a teachable moment.
So that's really all there is, and then what they need to do is start filling in their specifics, the things that we want to know. So my weight, that needs to be changed to 3 seconds. My speed, that hasn't been defined up there. It just said start the motor, so I need to know, am I going to run it at half speed? Am I going to run it at full speed? So am I going to run it at half, so 67? And then I need to give these motor ports names. So Vex has been very nice to us. They've actually rebuilt this toolbar for us to make it really easy. And they now have just put this right on the front page just to do the motors and sensor setup. So I go to my motors and I call this. The really nice part about 1 and 10 are designed for you to just plug your motors directly in. If they're going to use 2 through 9, they have to use a motor controller with it, or they will never be able to turn off the motor or change its speed. As soon as they plug it in, it will run full speed. So I can put it into 1 and say that this is my, oops. I always start typing mine with capitals. I either teach my kids to type in all caps or at least put a capital letter in front of theirs, because Carnegie Mellon does not type with capitals. So the nice part about typing with capitals is when I go here in a second to change my motor port, as soon as I type a capital P, I haven't compiled it. Oh, it should. Usually as soon as I start typing with a capital P, it'll give me a list of things to pick from that are reserved words. And since I have power motor with a capital P, they have nothing with a capital in front of it. It'll get rid of all of their stuff and only bring up my stuff. So I'll have a very short list of things to pick from. So once I'm done, I always have the kids compile first. Once they compile it, if there is any errors, it'll pop up errors. It'll tell you where they are. So if I'm missing this semicolon, and I go to compile it, it will tell me that there's an error right there, missing a semicolon, and they have inserted it for me. So you kind of have to teach the kids the difference between a white X, a yellow X, and a red X. A red X is something that it cannot compile past. A yellow X is a warning to let you know that it has made some type of change, and a white X is just informative that there may be something happening there that they didn't think was supposed to happen there. So anything red, it will not go past. Yellow and white, it will. And then they can download a robot and start running the program. So force the kids to do this pseudocoding, get that thought process down, type it the way they would say it. Now, if I want the motor to run for 3 seconds, then stop. Make them do that and then write the code. And you'll find that they're going to get a lot more successful when they start writing more complicated code. When you start getting into the PowerPoints, the things that trip the kids up the most are if statements. Once they learn how to use if statements, then they think everything has to use an if statement. And they completely forget every assignment that they've ever done up to this point, and everything now has to have an if. And typically most of their programs are just linear. It's just supposed to run straight through the program. The only time they need ifs is when it has to start making decisions where multiple things could be happening at the same time. And they'll start putting all kinds of ifs and things. They think they're getting more advanced in their programming, and really all they're doing is confusing the programming and making more things possible at one time, and then it starts going all over the place, and especially with their AGV. They'll have all ifs and no else statements, and then all of a sudden a condition will happen that they haven't accounted for, or 2 conditions will happen at the same time, and their thought process is just a little wonky on it. So do you have any problems that you have already currently ran into?
This is William. We've had some issues. Some of the students have had issues getting the program to start from the joystick controller by just the pushing of a button. Like they're trying to program like button D to start the process. So if you could talk a little bit about that. We haven't been able to figure that out too well.
The really cool part, and some of the kids figure them out early, is you have a lot of sample programs. So if I look, I have remote control, and if I open that up, there is all kinds of joystick ones already in here. So if I look at single joystick control,
we were trying the one with the to have one button to start something like one arm, or so it was very similar to what we wanted, but we never could get it to actually cooperate with the robot. So
okay, so here you go. And again, this is in and if statements. So they have assigned button 5 up. When I push button 5-1 up, we would like for you to run motor, arm motor at full power 127. When I'm not pushing that button, else turn it into a 0. If the button down equals a 1, they want it to go back down. So there's their 2 buttons. There's button 5 up, there's button 5 down. So if this one, the only reason they have an if and an else if is so that both of these can't be happening at the same time. And that's where the kids really start getting hung up and start getting tripped up, is they will just put 2 ifs. It's fine as long as you're a really good controller and you never push both of those buttons at the same time. The problem is arm motor is going positive, arm motor is going negative. Both of these situations could happen at the same time, and then the Vex controller doesn't understand. You're telling it to do 2 things at the same time. They're both true at the same time. So because they've put it here, they've put it in a hierarchy. This one will always overwrite whatever's happening to this one. So if you push them both at the same time, the up one will overwrite whatever's happening to the down one. So that's the philosophy of putting it as an if, an else if, and an else. So if I push this, allow it to go up. If I don't push it at all, then just stop it. Just stop the motor completely. Don't run it one way, don't run it the other way, don't return it back to another position. But it kind of depends on what your situation is like. When my kids did their, did I leave it powered up? I shut his program. The one gentleman I had, he actually went all the way through the AGV. He got it to follow the line. He got it to stop at the intersection. He got it to continue from the intersection after his 6 seconds. He then put the ultrasonic on front of it, and that worked. Then he got to put the joystick on there and get to control that. So he got to drive it around the room, put it onto the map, and then push a button on the joystick to get it to take over into autonomous mode and start following the line. So that was, I didn't teach them how to do that. They had to go into the sample code and they had to pull out this information to try to figure out how to make it work.
That's what the approach we took. I think what they did was they tried to short change that series, and I think they were just trying to throw an if in there, or just an if and an else or something. They didn't put I don't think they put all 3 of those steps in there.
Well, and again, this is trying to go up and down and that kind of stuff, and sometimes it's just that. And again, this is just a specific situation. I could do an until Vex RT button 5U equals 1, do something else. I mean, I can make it stay and stick at a point until somebody pushes that button. So keep running this while this is true. I mean, this code within the parentheses, I could put this in several different places. It doesn't have to be in an if statement. All this is doing is assigning the code to go look at the joystick sensor. It's the same thing as the sensor port. It just knows that it's supposed to be coming from the joystick. Now, do you know which keys you're running? Are you running the black keys or the new white keys?
No, we still have the black ones.
The black ones I've had nothing but problems with.
Okay.
We were very, very fortunate that my director was nice enough to say, yeah, go ahead and do the trade-in. So we sent back all of our black keys, and I think we got like $10 off a new key for every black key we turned in.
Mm-hmm.
So I think we got new. So I have had very good luck with the new white keys. Black keys, I had nothing but trouble.
Okay. Well, I
just kept losing connection.
Yeah, I had talked to one of the suppliers or something, and they said we could get by with the black ones this year, but next year would be required. Apparently some changes they're making that we would have to have the white ones for next year.
Oh, that doesn't surprise me.
So.
Well, you got to look at it, and this is always a good opportunity for you to talk to your kids, especially when you're doing cost analysis. You talk to them about, Vex is in the business of making money. Yeah, they want to make the stance that they're trying to educate children in the ways of robotics, but all in all, they're still a company that wants to make money. If I've got lots of schools out there that are satisfied with the kits that they have, I have to have some kind of longevity. I have to have a way that I can continue bringing in finances, and usually that's through the metal. Because kids cut up the metal and they bend it up and everything, and you need new metal. Sensors go bad and that kind of stuff. You would hate to think that a company like this would ever design sensors flawed so that they're going to break on you. But you never put anything past anybody. But yeah, they can easily just say, hey, we're going to change this programming, and if you change the programming, then the keys won't work.
Right.
But the nice part is RobotC is not. They're two completely different companies. So Vex may be the one that's deciding that something new is going to happen with the communications or with the competition, and RobotC is having to follow suit.
Right.
Because you've got RobotC and you've got EasyC. They are completely separate of Vex.
So the way that code was written, you had to hold down on the button. But we could actually program it to say let that button be equal to 1 somewhere else in the program, right?
Sure. You could say as soon as it's equal to 1, then I could continue on with the rest of my program.
Okay.
So I could come into this control structure. I could go into, that's not what I want. I want my untils. Wait until condition. So I can get it stuck. I can say wait until Vex RT button 5U equal 1, As soon as it does, then it will drop past this line of code and move on. See, the bad part is this is all new. This control structure didn't used to be there. So in the past, we would have had to written that out by longhand because they gave us untils, but they gave us these untils, and untils had anything to do with the joystick. So we'll just kind of go through some of these real quick. The kids will get stuck on this guy. They think they want this until button press, and they don't realize that the until button press has absolutely nothing to do with any piece of equipment that we own. The until button press is the little LCD that you can buy and put on your VEX Cortex to make it say something. It's talking about so that they don't need. There's a difference between an until bump, an until touch, and an until release. The kids think because I'm using a bumper, I have to use until bump. I wish they would have renamed it. It should have nothing to do. An until touch waits for a 1. An until release will wait for a 0. And an until bump will wait for it to go from a 1 to a 0. So it's just to allow your finger to get off of it. So you kind of have to teach the kids the difference between a lot of these things. You'll see in their programs they have an until button press and can't figure out why nothing's working. Their thought process is right. They're just using the wrong code.
You know, it's always good, too, to be able to open up and look at it, see what the hardware is doing while they're running their code. And they'll see exactly what's 1 and what's 0, what sensors are doing what when they run it. And that's a great troubleshooting technique.
Oh, and they'll also come up here and they'll try to go, I can't see my debugger window. Yeah, to use the debugger window, you have to be communicating with the robot. So you have to be downloaded and talking to the robot for that debugger window to be able to do anything. But it's just a learning experience. The more you do of it, the same thing. The more they do of it, same thing. It just starts to get easier the more practice you have at it. And if you run into some problems, let us know. Send us the code that somebody has. We can kind of troubleshoot it sometimes here in the beginning while you're just trying to learn for it. Half the time, if I've got kids that need solutions, I'll do things and take a screen capture of it. I'll write part of the program and take a screen capture of it so they can't just copy and paste it. Because they're so lazy they won't even type it. They'll just try to copy it out of an email and paste it into their RobotC. But yeah, you have tons of sample programs, and if the kids are really smart, they'll come in, and there is even a sample program, which I don't tell them. There is a sample program for a line follower.
Yeah.
They go into the line follower, there's your triple line sensor, and there's the code for it. Now, they have a display, so all this junk up here in the top, it just has to do with being able to show you, is the left seeing something, is the center seeing something, is the right seeing something. In the past, I've made my kids put in LEDs. And when the left sensor was hot, their yellow LED went on. When the center one was hot, their green LED was on. When the other one was hot, their right LED, the red LED was on. So, I mean, that's it. If this sensor, if this sensor, if this sensor, run these. I'm surprised they don't have them as if, else ifs, and else ifs, but it works.
That program tended to work pretty well. We tried that out first before we included that in our main code. So they will try out some of the sample programs, and then they'll adapt that to their program. Like you said, what happens sometimes, they get lazy and don't want to do the whole program. They want to just grab part of it and stick it in there and hope it works, rather than taking the time to get it all in there and check every step. They want to jump to the final product,
It's really interesting, too.
I can kind of tell when my kids have looked at the sample program. Kids are smart. I'll give them that. But to make an integer just for the threshold, most of them don't have that type of intuitive thinking where they're going to think ahead that, I want to write one threshold value with an integer and then it's going to replace. So all of a sudden when I start seeing the word threshold, then I come up here and I see an integer called threshold, and all of a sudden it's 505, that tells me, one, that they don't understand what the word threshold even means and that they've just basically copy and pasted the program.
Yeah.
I mean, they don't understand that a threshold is supposed to be my high value, my low value. It's supposed to be an average of those two.
Right. And we notice that value changes a good bit based on the time of the day and the shadows in the room and all of that. So
you want to have the line followers about 1/8 of an inch away from your object.
Okay.
The closer you are to the table, the more you block out those shadows, which is really kind of odd. They call it an infrared sensor, but it's not. If it was truly an infrared sensor, then it would be a yes or a no. Black would absorb the light and white would reflect it back to the sensor. Most infrareds cannot see analog values. So I'm not quite sure. This still may be some kind of infrared because it can see in the dark, but it doesn't work like most infrareds do. Most infrareds can only say yes or no. But yeah, the closer you are to the table, the more you'll start blocking out those shadows. I've even done that to the kids. I'll turn one bank of lights off on test day. And if they haven't tried to isolate their sensors, they'll throw all their values off.
Yeah, yeah.
But
I warn them about that.
And also, I like to show them this example because that threshold, by setting that threshold as an integer, they find that if you do shut the lights off on them, they change that in one place up at the top of the program, and they don't have to go down through their whole program and find every one of these and change every one of these. So they like the fact of calling these out at the beginning.